medical myself and teaching part.
So I clicked on it, it told me that I read Anyway, that's my. You have to get started.
Yes, please.
But only for 50 minutes. Like, that's good.
Well, we're installing Medium and trying to get it to work. So we'll keep playing with it, but if you can show it the first one. The first one.
Oh, no, yeah, that's your, whatever.
All right, it's 9. This is the Netconf working group meeting. I don't see anyone exiting the room, so I guess you're in the right room then. Let's get started with the meeting itself. Right, here's the note. Well, if you haven't read it before, of course, and you can read it right now on the screen, just to be sure that you're aware of the fact that anything you say or do in this group is a contribution to IETF. We have a couple of people who have volunteered to be on Jabber, but if you know how to run Jabber, would appreciate you taking a seat near the mic so you and watch the Jabber room for any comments or questions. While you're up here, use the box around the mic and stay in there while you're speaking. The blue sheets have been handed out. I see on this side, it's sitting on the front row, so someone can pick that up and pass it down that aisle. We also have Etherpad up on this link. It's if you want to quickly take a look at it and paste it into your browser, etherpad.tools.itf.org/notes/-itf-103-netconf. I'll give you guys a few seconds if you want to bring up the Etherpad. We would appreciate you adding comments or corrections into the Etherpad as you see people speaking. We'll use the minutes recorded in the Etherpad and of course validate them with the audio stream for any actions that are taken in the working group. Before we proceed, in full disclosure, I did want to let the work group know that I've had a change in corporate affiliation. I am now working for VMware, just so you know.
Okay, so just going over the status of current chartered working group items. The zero-touch draft, of course, is left the working group. It's been submitted for ISG publication. Not sure what the current status. I think it's been there for a month now. Did you want to add any update to this, Ignas?
Ignas Bogdanas. Zero-touch document will proceed quite soon. The next upcoming telechat is already full, so that will be beginning of December when that goes into that. So from a review perspective, there are a few units, but nothing serious.
Great, thank you. Then there's the Yang push suite of drafts. There's 4 of them: Yang push subscribe notifications, Netconf event notifications, and RESTconf notif. All of these drafts have just completed their last calls, and for the most part, waiting for Shepherd write-up. We are, of course, there's a closing of the window, the submission deadline window, which is just reopened, and some final dotting of the I's and crossing the T's that need to occur. But for the most part, they're moving out of the working group to Shepherd write-up state, and I will be the designated Shepherd unless someone else would like to volunteer to be shepherd. The only reason that someone would maybe like to do this would be because for myself, it'd probably incur some delay. I won't be able to get to it until mid-December, possibly early January, if it were to be myself.
Hi, Ignas Bogdanas again. So I would really encourage somebody from a working group stepping up into that, and probably we can have a couple of shepherds. Just because the documents seem to be mostly ready, and it's understandable that you have many things on your plate. So we might even have somebody who is rather new to this process and kind of try to train them into that.
Mm-hmm.
So if somebody is interested in that, please put your name forward.
Yeah, reach out to the chairs or even Ignas. Great. Chairs, I think, is probably the appropriate reach out. Send us an email. Next, there's the Netconf, RESTconf client server suite of drafts. These are still works in progress. We'll be discussing them today. Okay, and then also there's a UDP pub channel, also a working group document. Then there's the Yang push notification capabilities draft, and also another draft, notification headers and bundles draft. Both of these are works in progress, but neither are being presented today, primarily because the authors are the same authors working on the Yang push set of drafts, and they wanted to focus their attention on those drafts rather than these other working group documents. Okay, from the agenda perspective, first there'll be the presentation of the client server drafts, followed by the Yang push set of drafts, followed by the UDP pub sub draft, and then a couple non-chartered drafts, which would be subscription to multiple stream order originators and the inline action capability for Netconf. And then other area business. I should say that we have plenty of time. This schedule, I think, 2 hours on the schedule, but from the amount of time that the authors were requesting, we may have 50 minutes remaining. So lots of time for discussion. And if anyone else wants to, to bring up something that's not on the agenda, there's plenty of time for that as well. Anything else? Okay, hi, Kent, presenting the client server drafts. Since 102 in Montreal, all the drafts were updated and submitted as a set twice. Most of the issues that we discussed in Montreal have now been resolved, and a few extra issues were made as well. There are 2 remaining issues that we discussed in IETF 102. One being that which was called, should algorithm identities be moved from the IETF SSH client TLS common cryptotype modules to the cryptotype module, and the other being how do we add support for TCP QB lives. So this presentation only focuses on those 2 issues. As a quick recap, there is a set of drafts, and the relationship between the drafts is as it is on the screen. I showed this last time as well. The only new thing is the lines that are in purple, because if you recall, one of the issues were, should we move some of the groupings that were in the key store module to the cryptotype module. So those groupings got moved, and so those purple lines are just representing the using of those groupings from the SSH and TLS client server drafts to the cryptotype draft. All right, so first we'll just begin discussing the first item. Should algorithm identities be moved from the SSH TLS common module to the cryptotypes module? For this issue, you might recall we reached out to SAG and the security group several times requesting help cryptology experts to help us with this particular item. And last time we were fortunate enough to have some individuals from Huawei volunteer to help us with this. So I spent the last 2 or 3 months probably engaging with Frank and Hongwang from Huawei. And actually, I'd like to turn it over now to Frank to present this particular update, how we're doing on this issue. Oh, and I should mention Frank is now a co-author on this draft.
Hello, everyone. It's Frank Xia from Huawei, and I think it's very happy to work with Ken. We can proceed this series of draft into further step. So I try to give a very quick introduction of this time what we have done on this draft. In general, we have updated from my side, I have updated 3 drafts. The basic one is the crypto types draft. It includes several categories of the basic crypto algorithms, and we can use for other applications. For Netconf, currently we use we apply the basic algorithm on the Netconf based on the SSH and the Netconf based over TLS. Okay, so these are the 3 drafts we updated. Updated. Okay, so so firstly, the crypto type draft. Like I just mentioned, we reference a lot of existing very widely used applications such as the IPsec and the IKE version 2 and the TLS 1.2, 1.3 and the SSH. We do a thorough story and analysis of this draft and abstract all the widely used crypto algorithms, and also very important, they are also very safe algorithms. And we try to divide them into 6 categories. So there you can see. Oh, sorry. Okay, you can see the first one is hash algorithm. Okay, the second is the symmetric encryption algorithm, and the MAC algorithm, and the asymmetric encryption algorithm, and the signature, and the key exchange or key negotiation. So our basic idea is that we want these categories to be atomic and cover most of widely used basic algorithm, and they can combine together very freely for not only for Netconf. We think that in future they can also be used by other applications. So so you can go you can look at our draft for the detailed definition of the every algorithms identifier in each category. Okay, and okay, and that's all for the crypto types. But of course, this time we still have some problems. They need to be solved. Okay, the first one is we already have the 6 categories of basic crypto algorithms, but for how to define a public key pair and the certificate, how to define their algorithm type for the public key pair and the certificate. Usually, it should be a combination of encryption and the signature, right? Like what we always say, the ISA mechanism or the ECC. So, but currently you can see we already divided all the algorithm into very atomic, very specific categories. So, so ISA is not. It should be ISA should be a combination of the sum of the basic algorithm. So we are still not decided. Sorry, we haven't decided how to represent the public key pair algorithm and all the certification algorithm. Of course, there are 2 ways. One way is a fine-grained way. We can use our existing algorithm, combine them to represent the ISA or ECC. Other way, maybe we can just very simply to represent them. So I think this is a problem we still need to solve in the future version. So if you can help us, we are welcome. Okay, and after finishing the crypto types, and then we worked based on the crypto types, and those crypto types provide the definition of the possible used algorithms by the Netconf over SSH. So so the left question for us is that we already have got some key from the crypto types definition, and we also need to define the algorithm we used for the Netconf over SSH. So there should be some compatibility relationship between the key we used from the crypto types and the definition we defined here in the SH or in the Netconf over SH draft. So to clarify this relationship, we add some tables to justify what is the right mapping, what is the right mapping, the left is the wrong mapping. Okay, so you can see that these mappings are very straightforward. Actually, the left side is crypto types we used on the key, and the right side is that what we have defined in the SH configuration. So they should be compatible. So currently it's very easy because you can see that the Netconf over SH configuration configure every atomic algorithms on its configuration. So there's one-to-one mapping between the basic crypto types to the current SSH configuration. So this is a very simple example. We have 4 compatibility tables. The first one is about the not clear. Actually, this is about the MAC symmetric encryption and the key exchange and the hash algorithm and the signature. Okay, so they are all the mapping. They should be compatible with each other. So following the same idea for the Netconf over TLS, there should be still this kind of capability exists here. So we also do the analysis on the TLS 1.2 and the TLS 1.3, and also we look over all the TLS inner page, its algorithm inner page. So we know that for TLS 1.2, the TLS cipher, the TLS cipher seals is the most important part. It includes all the cryptographic mechanism which is used over TLS 1.2. And for TLS 1.3, there are 3 categories of cryptographic algorithms for it, which is TLS cipher seals, TLS signature scheme, and TLS support groups. So based on this survey, we decided that, okay, we choose all these 3 categories for both the TLS 1.2 and the TLS 1.3. But for TLS 1.2, only the first one, which is the TLS cipher seals, is useful for construct the compatibility mapping between the key and the TLS configuration. Okay, so also following the same way, we defined the capability mapping table independently for TLS 1.2 and the TLS 1.3. So the reason why we have so many tables here is that because current IETF draft has the limitation of the 80 or 82, right? 82 characters
72.
in one line. So because you can see our cipher seals is too long string. So we can only divide every mapping into a table. So there are 5 tables for each category, right? For example, this is the hash and the signature algorithms. It's just 2 examples. Also, we have the encryption, we have the key exchange mapping. Okay, this is for TLS2, and this is for TLS3. Also, they have the TLS cipher scheme mapping and and the key exchange mapping and other mappings. In summary, we want to give a capability mapping between the key and the configuration of our Netconf client or server. So yes, I think yeah, that's all. Yeah.
Yeah, just going back. Oh, sorry. Can you say we had a previous session? IETFs. Yeah. Okay. Let's see what's- Okay. Sorry about that. Good thing we have plenty of time on our schedule. Okay. Right. So back to this. Let's see if the back button works this time. Good. So the question was, should algorithm identities be moved from the IETF SSH TLS common modules to the cryptotype modules? The answer is no. We're going to leave them there. Those identities are going to be defined both in the SSH and TLS cryptotype modules as well as in the cryptotypes module. And we've created these compatibility matrices that are existing in the SSH and TLS modules to allow for the mappings to be formed. And currently those matrices are only implemented in text. There's not a Yang module level definition of these mappings. We're actually undecided as to if it's even possible to create Yang level mappings. How would we do it? Maybe some very complex must expressions, but it's unclear how it would be done. But fundamentally, the most important thing is in the text that it says clearly what the requirements are so that module implementers can, appropriately implement the requirements. If the client submits configuration with edit config or a Yang patch, then the server can determine whether or not an acceptable pairing has been provided and provide the error if not. So that's the fundamental approach that we're taking with this. And I think in addition to solving this question that way, we're also using the opportunity to expand the amount and number of algorithms being defined in the cryptotypes module to be a complete set of identities for all cryptographic purposes. Would you say that's a fair statement? Is that fair?
Yeah.
Correct? Yeah. Okay. There is interest in from other working groups to have other modules depending on the cryptotypes module with this expanded set of algorithms. And so that's where that's primarily coming from. But generally a good idea. Any comments or questions regarding this direction that we're taking, solving this problem? Okay, no? Okay, thank you. All right, so now we'll move to the next question that's being worked on, which is adding support for TCP keep alives. The last time we discussed how discussions with the transport area folks concluded that there is a need for keep alives at every protocol layer, at the TCP layer, at the SSH layer, TLS layer, even Netconf and RESTconf layers, if you wish to test for the aliveness of the application at that layer. Aliveness of lower layers, or testing for the aliveness at lower layers, really says nothing about the aliveness at the higher layers. So there's one reason for why you may want to do both. And similarly, aliveness checks at an upper layer should not preclude the aliveness checks at lower layers. And I think here Tim Carey was mentioning how you made there be like a degradation where some of the upper layer protocol has been corrupted or disabled, but you can come down and at least do TCP keep alives and see whether or not it's up at that level. So the question that we're stuck on currently is how to configure the keep alives at the various layers. We have not discussed this really at all on List since Montreal. So here we are talking about it. Okay, so I have an idea, but you may not like it. That's my disclaimer. Independent of this discussion, for a few months now, I've been aware of gaps in our current solution, specifically that we're missing the dependent or some dependent protocol layers, TCP, HTTP, and HTTPS. I withheld raising this to the working group because I envisioned much eye rolling and general exasperation, but now it seems like the time has come to broach this topic. So I'm proposing a draft restructuring of sorts, specifically adding in the missing TCP, HTTP, and HTTPS client server layers. Recall at the very beginning of this presentation, I showed you a picture of the current draft relationships. So in the light gray in the background is that picture, though parts of that picture are in black. So the SSH client server and TLS client server, the RESTConf client server were in that other picture as well. But new in red, green, and blue are the proposed potentially new drafts / modules that we could add to complete the picture. All right, so that's the idea. What are the benefits? Well, first, factoring out these dependent layers would provide a basis for future protocol models. Surely there will be more TCP-based models that folks in the IETF will want to define. So actually defining that IETF layer would provide a placeholder for them to make that extension. Similarly, surely there will be more HTTP-based models and HTTPS-based models. And so factoring them out would be sort of goodwill to the community at large. But that's not how we got into this discussion. We really are here to talk about keep alives. So back to that issue. Distinct layers would enable the keep alives to be configured at each layer. The configuration of TCP keep alives could be defined at the TCP client server models. The configuration of SSH keep alives could be defined in the SSH client server models, and so on, right? So then we'd have each distinct layer would have the configuration for how to configure the keep alives for that layer within its own model. And hence the issue that I mentioned before that we got stuck on, how, let me go back actually, how to configure the keep alives to the various layers falls out naturally. And so that's the idea. And the question to the working group is whether or not people think we should do this, or any other questions around what it would take to do it in terms of timing and effort. Anybody?
Comments? Questions?
Michael Abrams, I just want to say I like that we're not discussing if we should be able to set keep alives, because I want to be able to configure it at all layers, so I fully support the effort. And then exactly how to do it, I don't have a strong opinion, but this seems good to me so far.
Jason Stern, I'm just trying to understand the concept of having it like turn on keep alives at TCP layer is on a server. You're going to turn on globally, and then it's going to have keep alives for every TCP session. No. Or are you saying that every TCP session that's using Netconf?
Well,
what's the granularity of the control you're looking at?
Well, it'd be in the configuration data model, and all these are really groupings. So whatever your grouping stack is, in the case of Netconf, for instance, it's using, let's just pretend it's using the SSH client server grouping, which itself would use the TCP client server grouping. So you would inherit some keep alive configuration for the TCP keep alive from that grouping, and then likewise some SSH keep alive configuration from that grouping. And if ever we get around to it, some netconf level keep alive from that grouping.
Okay.
And it would only apply to that particular configured stack.
Okay, so
Not-
that's
not-
that
not global.
combination.
Yeah.
So you'd be turning on TCP keep alives for this netconf session.
Correct. And not for the entire operating system.
Yeah. Okay. Thanks.
So this is Tim Carey, Nokia. I will say, I think, the approach that having keep alives at every layer, it makes sense because, again, last time we talked about it, it's needed for that piece of it. To answer, Jason's question as well is that indeed this is within the context of the Netconf session, the TCP that supports the Netconf session. But I will say that as we were doing this for some of the stuff within the broadband forum work, that some of the implementations are that when you turn this on and you touch those TCP keep alives, it's actually for all the sessions, that there's some limitations in some of the implementations. Not that the approach still should be, the context should be the Netconf session, but sometimes the implementation says that the only thing that you can twiddle, the bit that you can twiddle, is on all the sessions, so on some of the implementations. So the refactoring, my concern with the refactoring is we've got modules coming out. I mean, there's just a ton of modules, and I get what you're doing. I don't know. You know what I'm saying? It's just, there's just a lot of modules now if you're going to do it for every layer. So I'm just wondering if the organization and housekeeping gets beyond the benefit, if the work becomes better than the benefit, right?
Right. And that's what I meant by anticipating the exasperation. I somewhat worn out the welcome here in terms of the refactorings we've done, and I get it, but I also see this as being the best way to solve this problem. And anyway. Yeah.
Michael Abramson again. So as there is like in Linux, there is a knob to turn this on system wide. So you could test that and see, would whatever you come up with for TCP here fit into IETF system, for instance, or would it make sense there as well? So, like a test of, is this module generic enough? And if it is, I would say yes, split it out, because I might want to support this both at a system level as default settings for also, and also just on the Netconf server sessions, so that the Netconf server would use the socket option to turn this on for just its sessions. And I would also like an IETF systems model, setting for the entire system.
Both. So we could, you're in support of this and also modifying IETF system potentially.
I'm saying at least spend 10 minutes on seeing, is the way you do the TCP part, is that generic enough that it would be able to fit into IETF system? And if I would support an effort to do that for IETF system as well, because as far as I know, there is an system-wide settings in at least some operating systems to turn TCP keep alives on by default.
Okay, we'll look into it. So just to speak a little bit to what's been said, so first off, let me, on this slide, it said Netconf keep alives could be defined at the Netconf client server model layer. So remember last time we discussed how would we go about doing Netconf keep alives, RESTconf keep alives, and we kind of concluded it'd be hard to do. I mean, the Netconf RPC model and the notifications, and especially when you take into account call home, actually figuring out how to do that. So it's really TBD, and I don't actually suggest this effort should try to introduce Netconf or RESTconf level keep alives. It's just a placeholder for if ever this working group wanted to define Netconf, RESTconf keep alives, could such keep alives be fit into the model at that future date. Similarly, while I don't put TBD there, there is such thing as HTTP keep alives, but they're really for HTTP 1.0, and in 1.1 it was by default. You didn't have to configure it; it was just by default. And HTTP 2 inherited that behavior as well. But also there's kind of a misnomer in that HTTP, when they talk about keep alives, they don't really mean keep alives, such as like actively testing the aliveness of the remote system, as they do a hint that's being propagated to the server to not close the connection within 10 seconds. It's more of like keep the underlying transport open is what they're really about. So I think HTTP keep lives is also effectively a TBD, not yet defined, and this effort would not intend to actually define how configuration for HTTP keep lives. Truly, it's just the TCP, SSH, and TLS where we would want to configure this. And back to the picture. So already we have the keep alives. In the current models, the keep alives are being defined at the Netconf client server and the RESTconf client server. So we'd effectively move that configuration from the Netconf RESTconf layers into the SSH and TLS layers, as well as into the TCP layer. TCP, all right, so this kind of goes to the scope of the effort. We really would want to factor out TCP client server. It's like primarily what we're talking, how we got into this discussion is because Nokia observed that the OpenSSL doesn't implement today TLS level keep lives. There's an RFC for it, they don't implement it yet. There's a discussion about that they should implement it, but it's still not implemented yet. And in the meanwhile, they have to do TCP keep lives. So we really need that TCP layer and the configuration of TCP keep lives. Do we need to have HTTP client server at all? And similarly, HTTPS client server at all? I mean, as the IETF goes, we generally are shunning non-secure protocols. So maybe we don't bother with HTTP client server, going to the comment made about the expanding number of drafts. So that light green draft, the HTTP client server, is one that I think is the least needed. And also factoring out HTTPS from RESTconf. Technically not needed, but you can see how it would probably be better to factor it out. There will be other HTTP-based applications, and having it factored out would be very helpful for them, as opposed to us bundling it inside of the RESTconf layer. So to the scope of the effort, that there are some opportunities to whittle this down, pare it down a little bit, and maybe do less than the full complete solution. But just want to bring it to the working group's attention. Comment?
Rob Wilson, Cisco. So I think separating the modules probably makes sense, but doesn't mean necessarily have to have separate drafts for them. So potentially you could bundle some of these modules together if they're relatively small, and that may reduce some of the overhead or process overhead here.
Mm-hmm. Thank you. And then just lastly, I think again to the scope of the effort. I mean, in thinking about, okay, I don't really want to take more work on for myself here, but in thinking about the effort, I would suggest that we define minimal module, right? So if we were to do TCP client server, it would just be the minimal IP address, port number, and the keep alive configuration. Any other possible TCP level configurations could be a biz someday in the future. I'm not really interested in solving that further scope problem. Same for HTTP. I don't know how many configuration parameters there might be for HTTP. I'm not interested in figuring it out. I just want to, have defined the little bit that we need to define to get this factoring out. And so it'd be the minimal effort, I think. At least that's the way I'd like to approach this. Yes?
Michael Abramson again. I wouldn't even need it per connection or IP or something. I just need a knob default on or default off for all sessions.
For the whole system.
No, for the Netconf, the TCP keep live for Netconf and SSH and so on. I don't even need that. So I don't know, is someone else expressed the need to do this on a per connection level? I just wouldn't want like a default setting on and off, basically. That's all of what I need. If someone else needs more, then okay, then we need to do more. But I'm just saying, I would, in a lot of scenarios, I think you just want to be able to turn it on and off, and you don't need to set it per destination or anything.
Yeah, understood. Where we would put a global setting like that is the question. Maybe IETF system, but these are the drafts that are open.
Default on and off for the Netconf server for all sessions that come in. I don't need it to do it per IP.
Mm-hmm.
I just need to say the Netconf server should default have TCP keep alive on. I don't need to say it for this IP range or something like that.
Rob Wilson, Cisco. So definitely support your suggestion saying that if you do the split out to keep them minimal, and the future, if they need to be expanded, that could be done in a future revision, just try and avoid features sort of creep effectively.
Right. And actually already that's the strategy we've taken. Like for instance, with the SSH and TLS, we're really just focusing on the minimal necessary to configure the crypto stack so that we can do it. But if you look at various SSH and TLS implementations, there's many more configurable options. We're not touching any of them. So more of the same in that regard, yes.
So Tim Carey Nokia, just to make the comment from Mikkel, is that we're using it for various applications, right? So there's a TR301 within the broadband forum that does call home, that uses TCP keep alives, and so there's the generic setting may or may not work. I'm not sure what works in that because it's on a stream based and we've got multiple endpoints that we have to talk to. But we've also started looking at the augmentation because we weren't waiting. What are you going to do, right? And so I think we can work with you on trying to figure out, how to get the best adaptation possible to work in different scenarios.
Actually, if people could collaborate with me, it's pretty much me doing most of this effort. But if I had some co-authors, I truly believe this could be done. By 104, we would be talking about it being done. And were there any other things that we forgot? And I think probably be going to last call around that time frame. So if we were to not do this, then we still have to finish up the cryptotypes thing that Frank presented, and also we would still have to figure out how to do keep lives, and I don't have an alternative proposal. That's the only proposal I have at the moment. So we'd spend some wheels on trying to figure out what the alternative proposal would be. We'd be looking into February time, maybe March timeframe anyway. This I can see what we could do. I don't think the effort is huge. If a co-author could help me, I do believe we could get it done really with probably just one more month worth of time. So, all right. I think that was all the comments. Any more comments? Anything on Jabber? No? Okay, great. Thank you.
Yeah.
So hello, everybody. This is Alex Clem. So I'm going to give a quick update along with Richard, actually on the suite of the subscription drafts. As Kent mentioned also earlier, really actually we don't have many updates, so this should be fairly short. But I'll take my time. Sure. Okay. All right, so basically, again, there are a whole lot of drafts that deal with subscribe notification, Yang push, and related things. What we're talking about here are the 4 drafts there from the top, the ones that are basically in a working group last call and have just passed. All the other drafts are basically dependent on this work and are, essentially pending until later. So for those drafts, some of the updates here. So one thing actually to mention, we had a slight name change for each of the titles of the drafts, just to make it more clear that they are all related and relate to the same topic area. So first of those drafts is the draft IETF Netconf subscribe notifications. And so working group last call is complete. It is currently since Montreal underwent 3 revisions. We're now in V18. Which basically have all the working group last comments addressed. Okay, so there's been a title change. There was an appendix use case, how to extend it for additional transports been added. Some minor nits like renaming the subscription identifiers to ID to make it less verbose and so forth, and a variety of minor editorial, textual, and so forth, tweaks and those sorts of things. There's one upcoming V19 that will basically be posted shortly, basically after basically now that that the site has been reopened for this. And basically there was a thread in netmod concerning updating the description of the XPath filter Yang object definition. So we will do that, as well as some text tweaks concerning basically the modification, deleting of subscriptions as a requirement that they need to come from the subscriber. And okay, so that's that. And thank you also actually for the extensive discussion and reviews that we received on the comment on this and actually on all of those drafts. So that was very helpful. So thank you. Second one is the draft IETF Netconf Yang push. On this one also same story. Working group last call is complete. It has undergone 4 revisions since last time. We're now in V20. Again, there have been minor updates to the text, some clarifications and so forth. Some very minor updates to the Yang module itself. So for instance, we changed the names of the object that have a sync in it to not include an age, those sorts of things. And there's a V21 also here coming up shortly to fix basically 2 very minor editing errors. And with this, I'll for the remainder, I'll turn it over to Richard.
So the changes to the Netconf notifications draft also were relatively minor, similar to some of the ones Alex presented earlier. Title change so that to align with everybody else, the renaming of identifier to ID. There's been a few discussions about the examples in the appendix A.2 and A.3, and somebody, I forget who it was, had asked for subtree and XPath filter example. So those are the changes which went in V14, and then V15, which is supposed to go in very soon, is, I think it's only a spelling fix. Okay, RESTconf notification, there's way more significant changes there, I think because that document didn't get as much love as the others previously. Again, thanks to all the comments we got from the people on the alias. The first major change was removing the configured subscriptions. That was the main topic of discussion, IETF 102 in Montreal, so we got rid of that, so it's dynamic only now. Secondly, the document was a bit of RESTconf, a bit of HTTP 1.1, a bit of HTTP 2, so there was a fair amount of cleanup there to align with RESTconf servers and events. For example, we used to start the subscription, we used to do a post on the URI. Now it's a get on the URI to align with RFC 8040. We removed a bunch of HTTP 1.12 specifics. You see way more RESTconf in the various names now than HTTP. Similar to the Netconf draft, there was filter examples added. There was a discussion on the alias past couple of weeks regarding stream XPath filter, how to do that in JSON. Fix A.1 appendix A.1 examples. We aligned the title with Netconf notification. So that's what's out there right now, V09 and V10, what should go in today. There's a spelling fix, but also what was mentioned for the subscribe notification draft. There was various discussions about what does a subscriber or a client mean, and there was a proposal for RESTconf to tie that to a RESTconf username. So that V10 with that text should go in today. What's next? So the various authors believe we are done or nearly done based on the work group last call comments. We would like, there's been discussions about this many times before. We would like those to go to the ISG as soon as possible as the process allows us to. And once those are done, the first slide Alex presented, or the second one, I forget, there's a bunch of other drafts which are dependent on those ones, and then progress will go on those ones. That's it. Thank you.
Any comments, questions? Okay, I'll just make some comments. Thank you, Rashad, for helping with the RESTconf notif draft. It wasn't one of the original 3 that we had discussed, but adding it, I think, was good, mostly because it actually helped us find some other issues, right, in the subscribe notifications draft. So it had a sort of a trickle cascading benefit, I think, beyond just sort of enabling us to allow Netconf and RESTconf to move forward together, which is a general goodness for the working group. So thank you for that. And also to the working group, as Shepherd, as soon as I received these drafts, one of the questions, in parallel to beginning the write-up, I'll also send out an email to the working group just asking those who had posted comments to just review that their actual, what they were hoping to see is there, and to let me know, or let the Shepherd know if it's not me, if there's anything amiss. But otherwise, great. Thank you.
Okay, thank you.
Right.
So this is Alex. So just one clarification. So when is it basically? So what is the process question? So basically, when is it being sent to ISG? Is it basically once the Shepherd review is complete and the Shepherd write-up is there? Does it then basically is sent to the ISG review? So is it basically serialized like that? Is that the process?
Yes, for the most part, yes. The Shepherd does the write-up, and then the Shepherd isn't necessarily always the chairs. But then the write-up occurs, and then the chairs discuss whether or not it's appropriate to submit for publication, which is equivalent or synonymous to going to the ISG. But it almost happens at the same time. So the Shepherd write-up, the concluding of the Shepherd write-up, and the submitting to the publication or to the ISG happens at the same time. Then what that really means is it goes to AD, Ignis in this case. Where it'd be an AD write-up, and he needs to schedule a telechat, which he just mentioned a moment back. It could be a month out. It's every couple weeks, but you have to get on the calendar, and so it gets on the calendar, and then that occurs. Then there will be a number of discuss items, right? So the various ISG members will have comments. All of them will ballot on your drafts. There will be discuss items. You will need to resolve all those discuss items. This isn't really normally in the view of the working group. It happens off the working group list. The chairs and the Shepherds are involved in that process, but that can take as long as it takes. I've seen it sometimes go quickly, in a couple weeks, and other times months, just depending on how it goes. Then that concludes. It goes to RFC editor. And then the RFC editor will look into other issues, and there'll be more back and forth.
Sure, those things are where I was basically mostly concerned basically with getting it really in front of the ISG. Okay, thank you.
All right, so next presentation, I think Taran.
Hello, everyone. I'm Tian Zhou from Huawei. And firstly, there are many feedbacks from the working group. What's the difference between the multiple stream originators and the UDP publication channel, these two drafts? Here is the relationship. The multiple stream originators draft is distributed extension to the YAML-push draft, and the UDP based publication channel is a transport for that can be used for both YAML-push and multiple stream originators. And this presentation, we are going to talk about the UDP-based publication channel. Firstly, I would like to clarify the design goal. We want to produce a UDP-based transport for the carrier routers. There are many advantages that compared to UDP, the UDP compared to TCP, and here we list some. We also want to support multiple encodings, including the binary, and we also want to enable options for extensibility and want to facilitate the distributed data export. We also get requests from last meeting to compare with some existing transport. Here it is. Firstly, the IPFix is designed for the flow information export. It do not support multiple other encodings such as XML, CBER, GPB, so on. And there's no YARN to IPFix encoding, and no mechanism for block message fragmentation, and no extension mechanism. And the other protocol is CoAP. I think it's an option for IoT. It's designed for resource-constrained device and network. It's not for carrier router. The message ID is 16-bit. It will result in a frequent wind-up for large amount of data when used on carrier routers. This new version, we add a part on how to manage the UPC. We augment the subscribed notification model just like this. And but now it's only apply for the configured subscription. We need to consider the dynamic subscription also. Here's the next step. Firstly, we need to consider how to manage the dynamic subscription. We may augment the established subscription RPC with the transport and the receiver information. This is not existing in current subscribed notification draft. And we also need to update the subscription EI model by adding the dynamic subscription support and add the encoding attribute to the receiver. And we also will align the document name with other transport document so that so that it can be clear what it is. And is there any other suggestions?
So Kent as a contributor. Well, actually, maybe first, just a general clarification statement. What this draft is presenting is a notif model. So we have like Netconf notif and RESTconf notif. This would be a UDP-based transport notif.
Yes.
How we might characterize this draft. And like with the other notif, well, the current notif drafts, they're really just providing dynamic subscription only support. Because we never really got around to thinking that we would want to have configured Netconf or RESTconf subscriptions, but but we do want to have configured UDP-based subscriptions, and that's how this draft came to be adopted, working group supported item, and also I think having dynamic subscriptions makes sense as well. So that's sort of the clarification of, I think, where this draft is. Second is, I think we need to be clear that what we're describing here is a new protocol. This should be a new binary protocol. We're calling it UDP. I'm not even sure we have a name for the protocol yet. We don't have a name for it.
The name is UDP-based publication channel.
We need to have a name for we need to call it something.
Okay.
But it is a UDP-based protocol. It has a new, it's defining its own message header, et cetera. It can contain different encodings, particularly. So anyway, it is a new UDP-based protocol that we're describing being defined as a notif. So then finally getting to my question, is defining a new UDP-based protocol making sense relative to making use of an alternative existing UDP-based protocol? And I know you discussed IPFix and CoAP. I guess with IPFix, one of the things you mentioned was that it doesn't support different encodings, but maybe that's okay. Maybe just a single encoding would be okay. For CoAP, you mentioned that the message ID was only 65,000, and I think the concern there is that IoT devices, their rate of transmissions could be very slow, but a high-end router could send 65,000 messages within a single second. So it would lead to many issues. But there, maybe if that's the only concern there is, maybe there's an opportunity for this working group to approach the CoAP working group to ask them if there might be a possibility to extend that message header. Anyway, I'm just exploring ideas, other ways that we might be able to solve the general problem, which the working group wants to solve, is a UDP-based notification message for subscribe notifications. But how we get there, I think we should still consider the solution space some more I think is my comment. Thank you.
Thank you.
Yeah, hi, this is Hank, working on the concise Yang telemetry draft, and we are using CoAP. And the message ID is for detecting duplicates. So if you expect having a duplicate in a 16-bit space, then you need a bigger message ID, but I don't think that is a concern. It can rewind in that scope if you don't expect duplicates in that dimension. The association between the request, also the subscription to the stream, is the CoAP token, and that's 8 bytes. I don't think that's the problem. So maybe message ID is a little bit misinterpreted here, I think. I don't see that it is a problem. But on the other hand, you want to have this inside the system. Like I heard between line cards, or it is not leaving the data store system component, I have the feeling. So maybe then having a listening server that is RESTful CoAP server is a little bit too much. Then you can just establish a UDP stream. It depends on the application. If it goes through the internet, probably CoAP is a good idea. If it is just for high volume inside a system, you can basically unpack all of the overhead you need for internet protocols there. Not being the devil's advocate at the IETF to say that we don't need internet protocols here, but you can strip a lot of that off.
On the mic.
I was just explaining that IPFix does leave the box. It's generated on the line card itself, and it goes out the box to a collector.
Yeah, this is of course correct, but I thought IPFix was used in a different place here for this purpose, and therefore has a different scope of application, I think, because of encoding. I thought it was an encoding alternative.
Well, just to add to that conversation, I've also done UDP-based logging where the log receiver was on the subnet to the line cards, and it would receive all the logs and then do aggregation and compression and deduplication, and then send them over the LAN.
Yeah.
So I think that's your point.
Yeah, but that's my point.
If
Yes,
it's over the LAN, you don't really have to tag it. And besides, if you miss one, what would you do about it anyway? Even nothing you can do. It's not like the router's going to keep.
Okay, and my last comment is anything but binary representation doesn't make much sense inside. If you're talking about burdened by TCP state, I think being burdened by something else that is binary is even worse. So I think it's rather obvious not to use human readable clear text formats like JSON or XML. I think it would defeat the initial purpose. I think I have the feeling of the concept of the draft. Okay.
I should say those requirements are from our customers. So we designed for them, and they have the requirements.
Hi, Rob Shakir from Google. I find that the whole section of this draft to do with any kind of reliable delivery and a discussion of how you should only really deploy this over reliable networks is underspecified. So our operational experience of having tried to put something UDP-based streaming into production is there are no reliable delivery channels. Like you have bits of your network where you can't possibly assume that all packets are going to get through, or there's no congestion because it's just not, like, even the amount of bandwidth you can buy there is not sufficient. And the cost of having to assume that the channel is unreliable is a lot of periodic replication of the data on the channel, so that you can deal with retransmission or dealing with retransmission. I would go so far as to say, as soon as you have to deal with retransmission, you might as well have used TCP anyway. And TCP, and then because you also get the advantages of knowing that reliably when you sent an event, it got to the other end. So you can reduce the number of times you need to stream data. So we don't think that it's actually possible to do over an unreliable channel event-based updates, because any system then can't really rely on it with any kind of latency. So I think you should probably add some discussion to your draft as to what the cost of doing this over UDP is, and really try and figure out how retransmission works in this model, especially if it actually works to a line card, which is kind of the motivation here, right? Because you're assuming then that there's a cache on the line card to have any packet within some known window to be requested. My suspicion and operational experience of having a few thousand devices that run telemetry at this point across number of vendors is that you will just go to TCP again as soon as you have to deal with these problems, which are kind of the operational reality. So I don't really think we should be pushing the industry in a way that doesn't really work.
Actually, the reliability supported in this draft is not the real reliability as the TCP. It's a kind of partial reliability. It's a trade-off between TCP and UDP.
Right, but the problem is now, how do I build any kind of system that relies on the data being there? So I can't, if I'm trying to do anything with interface statistics and I know that there might be fidelity loss because I've got lost packets, I can't rely on it there. You can't do anything event-based because an interface goes down in my network and then you don't have any way to react to it. You don't know that the state is there. So the natural requirement then is that you end up building a polling system to make sure that you have a current enough view or to reconcile. And our scaling analysis kind of shows as soon as you do that, you're going to end up with significantly more data than you would via TCP. So this scalability argument kind of falls down. So we've been pushing this entirely TCP based.
Kent, as a contributor, if you don't mind, just jump in for a second. What is the motivation for you UDP based? Is it the reliability or unreliable? I don't think that was it so much as the desire to enable the line cards to send the UDP packets having the same source IP and port, or maybe not port, but at least the IP address as the routing engine. That for the other draft that you're about to present, the multiple stream originators. So it's the desire for UDP is to enable that distributed source.
So we've looked at this. I think that there's a model whereby you have a distributed system that has different components that can each have TCP, right? Like, I think you're going to end up going that way if you ever care about reliability. If you say this is 100% unreliable, then I think you can kind of talk yourself into this UDP model. But if you say, I want distribution because it gives me more scalability, point to be proven as to whether that's really required, then you can still do TCP, a lightweight TCP protocol to the line cards. And you're kind of inventing a new protocol here, as you pointed out. So you've got a bunch of room to be able to design it exactly how you want. The source IP, I would suggest for debuggability, it's kind of a challenge. If you have N producers that are all producing with the same source IP, it's kind of like we have challenges around being able to know whether you're actually in synchronization with that system. If you've got N different producers, one line card stops producing data and you don't really know, you've got no metric to be able to alert on to say, oh, this source isn't sending me data anymore.
I think we're jumping into the next draft, but I think that draft is the idea is that the configuration model would allow you to configure the UDP to the system, and then the system implicitly distributes to the line cards and tells each of them, it's implicit. But if you were to do TCP, it would have to be explicit. The configuration model would actually have to configure, use this IP address for that line card and for each line card.
Yeah, I'm suggesting a bit of configuration pain is better for the overall system.
Thank you.
Hi, this is Henk again. If you are expecting to have congestions, you will have UDP datagram loss. I mean, apparently. So that's a fundamental decision you have to make. Do you expect congestion with your streams or not? If you have that expectation, which I think is likely, then you have to deal with retransmits. And then again, you should not reinvent a fundamental retransmit mechanism for UDP for every draft in the IETF. There is a good template for that in CoApp. That is a confirmable message. You can basically make every message confirmable, which is basically not recommended, or every 1,000th message, and you can then see how many you lost, and in that window can retransmit messages. That is like a little bit like TCP, but like the poor man's TCP retransmit. And also, if you are ending up with TCP in the end, again, there is, I call it reliable CoApp. The name is CoApp over TCP, TLS, and WebSockets or something very long. So there's an alternative also. But then again, why use CoAP? So I mean, there's a lot of things to be considered here. And my suggestion is to approach the thing-to-thing research group that is meeting here. There are 2 drafts in development there. The serious pattern draft, which talks about how to associate, let's call it data items that are somehow in series. And if there is this problem of retransmit discussed there, and if you have a problem that is not solved in general and you want to solve it with your draft, maybe we can create a general solution for UDP that other people can also use, so that this effect of recreating some new things for UDP to make it somehow look like TCP somehow ends finally. Also, if you decide to go with CoAP, there is the draft non-traditional responses, which can deal with basically every exotic thing you need that is not required at the moment satisfied with CoAP. So if you need something you don't find in current RFCs, please join the thing-to-thing research group for once, and then do look at the serious pattern and the untraditional response draft.
As far as I know, currently CoAP is only used for IoT like domain. But do you have any real example or real application that CoAP is used for routers or something?
An example for CoAP application is that with DOS working group, the DOS protection working group, we use CoAP as our basic transport protocol for the signaling channel. That's an application if you want to look at.
Okay, I would like to see.
And only because something was initially intended to be used in constrained node environments doesn't make it unfeasible for the rest of the internet. Just as a general observation.
Kent, as a contributor, just a quick follow-up on that discussion about retransmissions. I actually, when I first saw the message ID with the UDP, I never thought that it would be for the purpose of knowing when or to request for a retransmission or anything like that. I only thought it would be used for, number one, ordering of the packets received by the receiver, because UDP doesn't guarantee order delivery. So at least the receiver could do in order, reorder, at least have order delivery. That was the number one reason or motivation I felt that was for the message ID. And number two was for detecting gaps when a message was dropped, but not to request, just to know that you missed one. And so I never was I thinking that there would be a desire to try to build reliability on top of a UDP-based protocol here. Any other comments? Oh, yep, good.
Rob again, sorry, it was a long walk. I think that's an interesting operational mode of operation, right? So we've kind of said before, so with SNMP, I can poll the device. I know I get some stats back. Yes, maybe there's some loss in them, but I know at what interval I'm polling. In this mode where there's no reliability, then if the device just shuts up, you can't tell, right? Because you didn't get a sequence number to tell, and it becomes quite operationally difficult to not assume reliability when there's no guarantee that the thing at the other end is sending data. So this is kind of, I mean, we tried with this. We looked at it as the preferred way to start with, and this, along with internal collector deployment things about how you know when a collector can reconnect, how you deal with redundancy between collectors and those kind of things. I think it just makes more and more challenges here. So that's kind of why I would I think the draft could do with some discussion of how you actually operate the system like this.
Yeah, I agree.
Just to add to Rob's comments, I work for a company, we use streaming extensively from thousands of devices. Spent quite some time looking at UDP versus TCP and also discussing with potential customers. UDP was no, it has to be reliable. Otherwise, you need to build additional layer to ensure retransmissions reliability. You don't need this here.
Benoit Claes. So That's interesting because we were discussing the same thing that we've been discussing with IPFix for 10 years, right? Yes, the message ID in IPFix was there just to know about the order and just to know that you've been losing flow records. So the point is that for IPFix, it works fine because it's accounting, right? So you send information, if you lose one, okay, big deal. By the way, you can expect a router to keep the information and transmits. Sorry. So here, I think the key point is that if you rely on this mechanism for an event, like Rob was mentioning, it must be reliable. If you just going to send like monitoring information, you can use UDP.
Yes.
Just to add to Benoit's point, I think fundamentally S-Flow, IPFix have a different nature anyway, because we know that there's N flows on the device, we know that, or N packets going through the device, and we know that we only expect a sample of them. Therefore, losing one, we can never build a system around having, like, I don't know of any system that's built to say, with S-Flow or IPFix, I'm going to do one-to-one flow sampling, and I'm going to guarantee that I'll get every one of them. Whereas with telemetry data, if we're building systems that now split the control plane across the device and off the device, then we need it to be reliable, just like you would need some of this data internally to the system, like links going up and down, to be reliable for routing protocols.
So Benoit again, so it depends what you call telemetry, right? If it's telemetry, I'm going to push high frequency, all information. For me, it's like IPFix. You're sending flow records, even if they're not flow, whatever, right? Now, if you condense everything in your telemetry so it becomes an event, you can't miss it.
So this is Alex. Yeah, just one of the, basically in response to some of the items here, clearly there are different applications, right? There may be some applications where you require reliability, others where you say, okay, you lose one record, it's not a big deal. Another question is clearly how it is being used. So for example, if you use this for periodic, basically for periodic updates, you know basically that you are expecting updates for every period already anyway. So if you have a period missing, you would basically be able to infer some of those things as well. I do agree actually that we need to have the discussion basically of these operational things and the trade-offs and so forth in this. But at the same time, I think nobody is saying that this is the be-all, end-all transport for all particular use cases. There's one use case for certain scenarios where basically those operational scenarios that will that will be described would be applicable. So.
Rob again, just to respond to that, I think there's a few challenges with those assumptions, right? So as soon as you say, oh, I'll stream everything periodically, you're going to significantly increase the data that comes from the device by hundreds and hundreds of times, right? So actually, to make this system scalable, you probably want to only send things when they change. It gives you a significant advantage for large data sets. It also gives you a significant advantage for interfaces that are down on systems with, radix of 1,000 or so. Which is kind of common in today's networks. So as soon as you say, oh, I'll send things periodically, you're going to end up with these scalability concerns. And you probably are now having to deal with worse scale on the device of UDP periodic than you would be the cost of doing TCP for reliable. So yes, potentially. The other problem about periodic is that you don't actually know at the collector what you meant to receive. So if a whole line card stops sending, did the line card get removed from the system, or was it meant to send? So it's actually hugely difficult without lots and lots of other accounting to know what you should have been sent during that period. So I see why. The third thing I just want to say is we're inventing a new protocol here to send telemetry data. Let's not invent one that we know is flawed and only works in like a small number of cases, because that's just going to complicate things.
Just very quick response regarding the on-chain versus periodic. I agree certainly on the basic trade-offs, but actually the subscriptions both can support either, right? I mean, depending on the use case, a user or basically they will decide whether they want to have periodic or whether on-chain is actually more applicable for that particular application. If you want to have a continuous telemetry to do some kind of whatever statistics, trend line analysis, and so forth, for those types of applications, you might still want to have periodic, right? Not every use case requires on-chain.
That's true, but I guess the point is that there's some data underlying that you do want to sample like that, right? But that still can be This doesn't mean that the system can't support sending data periodically. It's that there is a significant amount of data that won't need to be sent. So what I would encourage people to go and look at is to look at the data that is being pulled from devices. This is what we've done. And then look at what the proportion of it that is event-based versus periodic, and do some calculation as to what the data volume is. So we have this for the scaling analysis and the gRPC-based telemetry, where we can show significant reductions based on this. But even though that some data is being sampled and sent periodically because it needs to be sampled like that from underlying hardware sources, for example.
Related question. It's been a while since I looked at the draft, but I remember there's previous message ID, and that's how the receiver knows that some messages have been lost. But if you're not receiving any messages, how do you know that there's messages lost? So we'll have to do a UDP keep alive draft, or?
Maybe we can include it.
I'm sorry?
I'm not sure. Maybe we need this keep alive information. I don't know, but this is something we need to consider.
Okay.
But we also have in the other draft we have some mechanism to solve this problem, partially solve the problem.
Benoit Claes. So in IPFix, we solved that with SCTP. And we had a perfect solution where actually you would have a stream which is reliable, unreliable, or partially reliable. So depending what you're sending, if this is monitoring, it would be unreliable. You miss a couple of information, fine, no big deal. You might be sampling anyway on a router. Partially reliable, you do your best, or reliable if it's event-based. That's how we solve that. However, SCTP don't pick up, and it's an issue on line cards, right? On line cards of routers, I mean, you're going to have a CTP session directly from all the line cards, or actually, it comes back to an operational issue, right? And I think Rob mentioned that. How do you identify your device? A router is like one IP address, or it's a sum of IP addresses, one per line card.
Sorry, I do not understand your question, the question part.
It's not a question, it's an observation that we've been looking at those issues like 10 years ago, and it becomes like more an operational issue. What do you want to solve, right? Think about that, and then you will have the solution for your protocol.
There are several, as we listed here, there are several design goals. Firstly, we want to build a distributed data export, and then we want to maybe to speed up the transport. We may want the hardware to encapsulate and to process the packet. So we need a simple mechanism, not simple transport, not like TCP.
Well, again, speaking as a contributor, I think the message that I'm getting from the working group is you probably need to look at the data set to see, do you need a UDP-based channel? And if you need reliability, then and you're going to build reliability into this with the sequence number, why not just use TCP? So I think if I understand, look at the data set, compare it between trying to transmit it reliably and unreliably, and see what is the impact of losing packets. And as Benoit mentioned, if it's monitoring data that you're looking at, big deal, you lose a few packets. But if you're looking at an event, you can't afford to lose it, then you have to build in reliability into the protocol. What is the cost of doing that?
Yes, I agree. Any other comments?
I'll just, as a contributor, just one more comment. I heard or learned last night that the, I guess it's the co-op working group, but there's an effort that's been going on for a couple years now to do a co-op based broker pub-sub mechanism. I don't know much about it, but we should learn more about it and see how it might be usable in this space as well.
Okay.
Let's move on to the next presentation.
Okay. Okay, this is about the multiple stream originators. This one is a generic distributed extension to the YAM push work. We have several use cases. The first one is the router, the carrier router scenario, and we want to push data directly from the line cards. And the other use case may be useful is the IoT scenario, and the collector firstly subscribe to the border router and distributed the request to different IoT nodes, and the IoT nodes can push data directly to the collector. Here is a solution overview. The publisher contains two roles, the master and the agent. And the master have a subscription server, and the agent contains the component subscription server. A typical operation is like this. The subscriber first send the global subscription request to the master, and the master will decompose this request into multiple component subscription and send to the component subscription server. Then the different agent or master will push data directly to the collector. Here, to achieve this, there are many interactions necessary between the master and the agent. For example, the agent needs to have a registration with the master so that the master is aware of them and manage the life cycle. But in many scenarios, like we mentioned, in the carrier router, the interaction between the master and the agent will be an internal implementation. So currently in this draft, we consider it out of scope, but we list there some possible interactions. One key point to this idea is the subscription decomposition. The master will disassemble the global subscription to multiple component subscription and distributed them to the corresponding telemetry source. To achieve this, a reference implementation is like the master may need a data structure and typically a resource location table to keep track of the mapping between the resource and the corresponding location of the subscription server. And another key point is the publication composition. Firstly, the receiver will recognize data records associated with one subscription according to the subscription ID. And the second step, the receiver assembles data generated at the same time period based on the recording time consisted in each data record. And in addition, the server may need to know the number of component subscriptions. So here we propose to use a list of publisher ID. We will add this to the response of the established subscription and the modified subscription, and also add this in the subscription started and subscription modified notifications. This part we may need a YAM model by augment the existing subscription notification draft. The other key point is about the subscription state change notifications. We know, in addition to sending event records to the receiver, the master must also send the subscription state change notification. And here we we ask for all the subscription state change notifications must be delivered by the master publication channel, which is the session between the master publisher and the receiver. Then when another tip is when the subscription decomposition result changed, the subscription modified notification must be sent to indicate the new list of publishers. And next step, we are going to add the YAN model to show how to extend the existing subscribed notification model. And is there any other issues you consider to be added in this draft?
Kent, as a contributor, can you go back to your previous slide, the one that said is the diagram and it had the red box that said out of scope? Yeah. Why is it out of scope?
As I mentioned, in some scenario, like the carrier routers, this is kind of internal implementation.
So
between the main board and the line cards.
Right. Okay, so I think that this being out of scope is dependent on the conclusion of some of the operational requirements that we were discussing a moment ago. Going back to Rob's comment from before, a little more configuration complexity may be warranted if we're, for instance, needing to configure TCP instead of UDP, in which case it would have to be in scope because you would have to be configuring what is the TCP interface, at least for each line card to use. So I think what you're saying is that it's out of scope here because the expectation is that from using UDP, the routing engine can implicitly, internally communicate to the line cards. And
yes.
Okay, so there's that assumption, which I think is still TBD, is what I'm thinking.
Okay, we may make this TBD. But my concern is this part is a little bit complex and may vary from implementations. So I'm not sure if it can converge in this draft. That's my concern.
Okay, Mahesh, as a contributor, if you could go down a couple of slides, I think where you talk about.
Down?
Yeah. Yes.
Okay.
No, maybe the next one. I think where you talk about being able to reliably indicate a change in the subscription. I think it's either this or the next slide.
Yes.
All the subscription state change notification must be delivered. Now, when you say must, that means you're thinking about a reliable channel here, right? For delivering that change in notification?
That's an interesting question. And from the message layer, no, it's not. We do not consider it must be a reliable channel. So maybe in UDP case, maybe we need to consider.
This is Alex. So also just to add or basically respond to that, I would not mix this actually with the earlier transport discussion. The goal certainly basically for the subscriptions per se has always been to basically make this make the fundamental mechanism reliable so that you can avoid having to poll things. Now, obviously, with this case, if you have a new component subscription that was added or something that was removed, that is an event that you would need to know or that you would want to know certainly as a collector. Therefore, basically, it is something that needs to be notified. We've had some internal discussion whether it should be subscription modified or whether there should be another type of notification. But either way, it is an event and support that should be foreseen basically as part of the control channel. Now, if you want to have, and again, this is basically for the control part of this. Now, for the actually telemetry stream, whether this is reliable or not and support, that's a separate issue. I would separate those discussions. But this one would be needed for reliable control channel, so to speak.
So Kent is a contributor, maybe as a chair, I don't know. The motivation for the working group, particularly adopting the previous draft, this draft is not yet adopted, but the idea that this draft is discussing was one that was presented at the time that we adopted the previous draft, which was the goal to support line cards to be able to send messages themselves directly, as opposed to trying to forward them to the routing engine in order to for the routing engine to send them, because from experience we know that the internal backplane, the fabric, is not having enough bandwidth to transmit that much data. It's just not possible. The line cards have to be able to send directly themselves. And in fact, things like encryption actually is probably problematic. So going to the operational requirements, are we actually thinking that for these very high logging scenarios, would the destination be an internal receiver, something that on the LAN, something that itself would collect the logs in unencrypted form, do deduplication and analysis, compression, even itself could convert it to binary. The need for binary, you don't really need binary in the LAN. You need binary on the WAN. When we talk to customers, their costs for bandwidth over WAN is expensive. That's when they care. They don't care about the bandwidth on the LAN. So I think if we get our heads around what are the operational requirements, what is the problem we're trying to solve, maybe some of this will become more clear. I still strongly support the notion and ability for sending logs out the line cards directly. That's an important problem to solve. But the motivation for it being binary, the motivation for it being UDP even, I think we should go back to asking if that's really important to solving the problem here. Yeah, there's a comment.
Michael Abramson. So it struck me the whole thing about line cards and it being on box. I have the one use case where I might have a Wi-Fi access point that basically doesn't have an IP address. So I'm speaking some kind of protocol to it, or I don't want it to send anything, so it's going through me. But it's a different device, and I want to expose this in Yang so that the Wi-Fi, I'm the Netconf server, but I'm configuring the guy over there, and I still want to expose to my NMS that these are two different devices. Isn't that kind of the same problem here? Don't we want a more generic approach in how to expose this in Yang and Netconf and how to handle this? Because isn't this the same thing? If it's a line card that is on its own computer sitting in the chassis, or if it's something else, you're acting on behalf of that guy. I mean, I see many different scenarios where you need the same concept. So can we make it more general?
Yeah, I think you provide an interesting use case, maybe similar to this IoT use case. And so we actually, I think this framework is like a generic one.
So I think my problem is there are very we're talking about okay, how do we what's in the UDP packets that is streaming the telemetry? It's
that's another
different thing. Yes, I know, but it's so this here it's talking about subscriptions and so on. But isn't this just configuration? It's not me specifically. I'm doing this for another guy. He's I'm controlling him, so it's not me. Don't we need a more generic approach to that? And do we actually need to talk about what the configuration is? Instead, isn't it how do we do this generically? Isn't that what we should be discussing? You're talking about subscriptions here and so on, and how to talk to that guy or what to actually configure. But don't we actually need just a best common practice of exposing this entire concept of different devices managed through one Netconf server?
I have a response, but I think Rob does as well. Is for this question, Rob? Yes, please go ahead.
I completely agree. So in the gRPC base, to both telemetry and configuration, we added a generic way to be able to make a path be addressable to a certain target that the managing entity deals with, and it's used for both telemetry and for configuration. I think having case-by-case solutions is made the point. I don't think it's optimal. I think having a single way that you can say there is this management agent that is responsible for this other domain is super useful for many, many cases.
Okay, so up leveling the problem space. Great. Okay, and I think my closing thought is it's not really on this draft, but kind of to the other one as well. Currently the Yang push and friends drafts are almost out of last call into Shepherd write-up. We, as working group, we've only yet defined support for dynamic subscriptions. We do not yet have any support for configured subscriptions. This draft is on its path towards enabling support for configured subscriptions, but I think that there may be other paths that we could explore that would get us there faster, specifically HTTP-based push mechanism, something along these lines. I don't know, maybe somebody would be interested in putting together an ID to propose another notif, right? So the nice thing about the way that we've constructed deconstructed the Yang push notification drafts is that we do have all these notif mechanisms. So it's kind of a Swiss Army knife. It's great that we have a UDP-based mechanism available. Certain deployments will use it for their use cases. Others won't because it doesn't match their use cases. So I think, though, we should also consider other notif mechanisms that would enable us to have configured subscriptions. So that's sort of my closing thought on this.
I think the idea is become mature and the solution and the scope is kind of clear. So I'm wondering if I can ask the working group to adopt this document.
I think before we get to the point of adoption, I think we probably need to address the question that Mikhail just raised, which is, do we need to upscale this problem definition before we get to the question of adoption? Maybe we should consider that first.
Okay, thanks.
Okay, great. So our last presenter, Chin. And we have to jump to here. There we go. And here.
Good morning, everyone. My name is Qin Wu. I'd like to draw your attention to this new idea. Actually, this draft has been around for a while. We actually submitted in the last IETF meeting, but didn't get it discussed. And we have a few discussions on the list with Robert Wilton and about this idea inline action capability. Because here, what we like to do is to use this capability to provide the bank operation and can work together with the protocol operation. But many discussions about whether there's some alternative mechanism we can use, such as configuration template. And so we do some analysis and so before this meeting, actually we prepared the draft update, but I missed the deadline. So we just post our new version, so sorry for the late. So for this draft, we want to recap a little bit, provide several observations for the action. Actually, Netconf actually doesn't specify how to handle this action. The reason is because the action get introduced in Yang 1.1 after Netconf 1.1 get published, and when we introduce NMDA and the action, we add the constraint for this action. They only can be invoked on the operational state data store. So we think it's very limited. So we, track the early discussion on this. Actually, there's some statement to said actually from the Robert Wilton, and this kind of restrict can be relaxed. Actually, can be applied to some other conversion data store. So that motivated me to write this draft. So we try to investigate how this action can be applied to other conversion data store like running data store or startup data store. So here is the use cases, and we have some many discussion about this. I think the simple cases we bring here actually is suppose you configure the VLAN tag range on the trunk interface, and you may leverage the configuration template. If you actually configure the trunk interface with VLAN tag value one by one, actually that means that you may, have you may need to a lot of signaling traffic. Actually, you may, but we have some other way because you have the configuration template, and you can define the young data model to allow you to configure the trunk interface with VLAN tag range. With such kind of range, you can maybe you can greatly reduce this signaling traffic. You only need one program message to carry this configuration data, but it still actually cause a large packet size. So go to a little bit further. Actually, if you actually configure trunk interface with several VLAN tag range, the VLAN tag range is not discrete. So in this case, actually, you may do a lot of data retriever. That cause even a lot of the protocol message exchange. So what we like to do is optimize the Netconf protocol to provide such a bulk operation. If you can merge the VLAN tag range, several VLAN tag range into one VLAN tag range, actually you only need one protocol message exchange. So what we propose here is inline action capability here. This actually can be applied to various different protocol operation like edit config, edit data, or get data. And the idea is we introduce the operation attribute. For example, under the edit config, actually we can introduce two new operation attribute we call the record, merge, record, split. Actually, they allow you to merge the, for example, VLAN tag range or split the VLAN tag range. If you can allow such kind of feature, you really actually improve the Netconf query efficiency, and you only need actually one query to get all the information you needed. Here we gave the example for this operation attribute we call the record merge. Actually, without the inline action capability, suppose you need to configure the trunk interface with two VLAN tag range, and but you really want to merge them into one VLAN tag range. So what you can do with the existing solution, for example, edit config, actually you need to delete these two VLAN tag range first, and then you create a new VLAN tag range with this one. So in our solution, actually, we have the inline action support. Actually, we can, just introduce the record merge attribute to indicate to server to use the configuration template to merge the range into the one range in the server side. So also we want to compare the difference. Actually, for without the inline action capability, actually you need to more climb the computation, because you need to figure out how to merge several VLAN tag range into one range. So that's the overhead we really want to avoid. Another case actually is we call the recorder split. Actually, you may have one VLAN tag range you want to split into 3 or 4, and with the existing protocol operation, we also use edit config. Actually, you may first need to delete the VLAN tag value, and then you can you create another 2 or 3 VLAN tag range. So this actually is a cost actually you introduced. But with the inline action capability, actually you only need to actually indicate to the server to do the VLAN tag range split. So this can be happen on the server side. So the advantage is you don't need to rely on the client to do the more range computation to split the range. So this is the basic idea. I like draw your attention actually. So the summarize what we propose here. Actually, we want to use this inline action to embed into the protocol operation to improve the Netconf query efficiency. Actually, we call this bunker operation. Maybe the solution, the example we provide here is very limited, but we think the intention is to really improve this kind of Netconf efficiency with this bunker operation. We may introduce some group ID. Actually, you can actually do the bunker operation with this kind of group, so they can greatly improve the Netconf query efficiency. Yeah, that's all. Yeah.
Yeah, Michael. So I don't know. I haven't read the draft. If I understood correctly, is this only for when you change the configuration, but the end result operational state does not change? Is that the only? So you're splitting the range into two, but the effective, in effect configuration on the line card or whatever, it never changes. Is it only for that type of configuration, or is it also, or is this also like you split it and then you delete one and you do that in one operation? Okay, so you had the example 1 to 5 and 6 to 10. You can merge those into one record.
Yeah.
This changes nothing in real life. I mean, the line card, the hardware doesn't get reprogrammed by that operation. You're changing the configuration, but the state of the device doesn't change. Is it only for that type of operation, or is it also for deleting one of the VLANs in the middle? It's for both.
Yeah, I think right now we support both. Actually, the motivation we can have the merge the discrete the several VLAN tag range into the one, allow you to do the better Netconf query, But split actually, we also support, we in some cases, you may need to delete some of the value from the VLAN tag range. So we provide such capability. In some cases, actually, we need to support both, and then we can actually optimize to merge several range into the one range.
Yeah. So do you see this as is this a optimization in number of transactions, or is it processing power on the server or on the client, or what are we?
We don't want to add overhead to the client. Actually, maybe you just need one transaction, but this actually transaction, you send a request to the server. Server actually will using some existing mechanism like configuration template to actually merge the range into the one. Actually, all happen in the server side. Actually, you reduce the overhead on the client side. Yeah.
Rob Wilson, Cisco. So I'm still not convinced that this particular use case is actually a problem. I'm not convinced there's a scale issue in terms of configuration here. Even if you split out the number of VLANs over, I don't know, hundreds of interfaces and things, I still think the amount of config is going to be, I don't know, 10K, 20K or something that'll be small in terms of message size and consuming it. So I'm not convinced by that aspect that there's a problem here to be solved. In terms of if you want operations to do more advanced VLAN manipulations, i.e. breaking tags or inserting tags into particular strings, for example, then yes, that's okay. But I would think of those maybe just being RPCs potentially on a VLAN model is how I would implement those. So then coming back to the general inline actions, I'm still sort of conflicted as to whether this is a good thing to do. I think this more generally is about transactions and saying, I want to give a sequence of events to the server as one transaction and for it to perform all of these things and either succeed or fail. So that's the guise I would look at this problem rather than just adding actions into configuration requests. But even with that, I still question whether that's a useful thing or not. I'm not convinced this is a problem to be solved at this stage.
But you say the example we are giving, actually, we use add config as example. If you, you really modify the VLAN tag range, you do the merge and split, actually, you may need, because you may operate on some list, the key index cannot be deleted. So you have several discrete range, actually, so you need to, delete the several discrete ranges first, and then you create a new range with a larger range. So that's a deficiency of the Netconf. We think we really want to address this.
Okay, so that's a different problem potentially to solve. And I think, again, you need to look at the data model that you're talking about. So the one that I've been through, IETF, doesn't have that issue, as in the VLANs are just information on a sub-interface. So it's not actually something where you have this concern. It's just manipulating that string. And the ability of a client to mangle VLAN IDs into a string is probably bordering on trivial to do. I mean, that's an easy thing to solve. So it might be that your data model is different, and then hence there's a different requirement coming through from that. So I'm happy to look at what your specific data model is to see what the change is, what's different.
Yeah, we do have such kind of model. We can show you offline about this. Yeah.
So Mahesh, as a contributor, adding to Robert's concern with why we might need this, is the problem specifically for a case where we're talking about a range that we're trying to specify, whether we're trying to expand it, break it up? Is that the specific use case that we're looking a solution for?
Yeah, the case we gave actually maybe is kind of limited case, but we really want to generalize this idea. The general idea actually we can provide the bunker operation for Netconf for protocols, so you can actually improve the Netconf efficiency. And here we give the example is the VLAN tag range value. The value actually is integer type. Maybe there's some other case actually VLAN tag value actually is a string type. You also do this split and merge operation. So
what other use case would you have?
Yeah, some case we haven't bring up actually is you may transfer some learned configuration into the static configuration or dynamic configuration data. But we think we only talk about focus on these cases, but we have some other cases we haven't bring up. Yeah.
Okay, I think maybe if you bring those cases, it might help the work group appreciate or understand the problem a little better.
Yeah. We can do that. Yeah.
Kent, as a contributor, I agree with Rob. I don't understand the motivation for wanting to solve it. Like, I guess scalability, efficiency, but does it really get to the level of concern that we need to solve the problem? The solution seems like a very point solution, and the fact that it's Netconf only is concerning. I would request that we have a solution that works for both Netconf and RESTconf. If it is truly just a transaction-like mechanism, and I think that's what Rob was saying, then maybe enabling Yang push to be worked, to be used by Netconf would be another way of enabling something like this. Going to Mahesh's comment right here, if it's truly just for ranges, then it seems like maybe we'd have to have a data type, a type def range, and then this operation would be available whenever that type def was in play. It's just unclear at the moment. I guess going to Mahesh's last point, more examples, data analysis. Currently it's not clear why we would want to pursue this.
Yeah, I think intention we provide such kind of solution. Hope we can generate this kind of solution not only apply to the Yang push, but also can apply to the existing Netconf operation. So not limit to the the existing Netconf protocol operation. So Yang push can we haven't investigated how this can be applied to the Yang push, but that's a case we think maybe first we need to clarify the prominent space first, and then we can go into deeper about that. But at the current stage, we don't think we should go a little bit further to apply to the Yang push.
You're saying Yang push, but you mean to say Yang patch, right?
Yang push, not a Yang patch. Yeah.
How is it related to Yang push?
Oh, you mentioned the Yang patch. You talk about Yang patch, right?
Yang patch.
Oh, sorry,
right.
I missed that. Yeah. Okay. Sorry about that.
No worries. Any more comments, questions? All right, so we're at the top of the hour. The blue sheets are up here. If anyone did not sign the blue sheets, please come to the desk. Thank you. And otherwise, great. We used up all the time. Thank you.
Well, I signed you in. Thank you. Signed you, so I signed you in.
Thank you.